Good day, guys. This is the work energy and power question. It has to do with the lift or the vertical motion. It says a lift arrangement comprises an electric motor. Here's an electric motor, a cage and its counterweight. Here's a cage and its counterweight. The counterweight move vertically downwards as the cage move upwards. Okay, the cage, it says it moves upwards, so the motion of the cage is upwards. It's very important. And the counterweight, it moves downwards, right? Now it says the cage and the counterweight move in the same at the same constant speed. Very important. So the change in kinetic energy there, it will be zero. Right, at constant speed, it means the initial velocity and the final velocity are equivalent, but they're not zero. Refers to the diagram below. Now, it says here the cage carrying a passengers. This cage, it has passengers. It's like a cable, it's like a lift, vertically upwards at a constant speed, covering a displacement of 55 meters in 3 meters, in 3 minutes. So the displacement that it covers there, it's what? It's 55 meters. 55 meters, that's the displacement, right? And the time it takes, it's what? It's 3 minutes. Have to convert that minutes into 180 what? Seconds, right? Same, if this one it travels the displacement of 55, even this one when it moves downwards, its displacement is what? Is 55 minutes, and it takes the same time, which is 180 seconds, right? Now it says an electric motor provides the power needed to operate the lift system. Ignore the effect of the friction, which is the F friction. The F friction as well as the friction there in the motor. So guys, now what are we going to do here? This counterweight, guys, it has a gravitational force that is acting downwards. It's a gravitational force of the counterweight, and this cage, it has a gravitational force. It's an Fg of the what? Of the cage, right? Now let's answer the questions, guys. And also there's a tension there, and there's a tension there in that direction. So they're experiencing tension in opposite direction, and those tension, they cancel, guys. They cancel. So only forces that are acting there, it's the force of the motor, and the weights, there. Now let's answer the question. Now the question, it says define the term power. The term power, guys, 10.1 is the power is the rate in which the work is done, rate in which the energy is transferred or expanded. Calculated the work done by the gravitational force of the cage. So it's 10.2.1. It's the work done by the gravitational force on the cage. We're going to say mg, which is Fg, change in y, cos theta. So the mass is 1200 and the displacement is 55. Cos, since it's going in an opposite direction, it's going in opposite direction there. The cage, the gravitational force, because the cage is going up and the gravitational force is going down. So the answer there, it's going to be negative 6,47 times 10 to the power 5 joules. And then 10.2.2, it says they calculate the work done by the counterweight. The counterweight is the gravitational force that is acting on it. So is the work done by the gravitational force on the counterweight. It's going to be mg delta y cos theta. So sorry, the counterweight mass is 950 times 9.8. Guys, there's a 9.8 here, times by 9.8 times by 9.8, and the displacement is 55. Cos, the counterweight is going down and the displacement is going down, so it's going to be cos 0. So the answer there is 5,12 times 10 to the power 5 joules. So let's go to the last question. It says calculate the average power required for the motor to operate the lift arrangement in 3 minutes. Assume that there's no energy loss due to heat and sound. So this is 10.3. So we wanted the power. So getting the power, we use the formula that says W is equal to change in T. This is be the work done by the motor. Or alternatively, we can use this formula that says average power is equal to force, which is the force of the motor times by the constant velocity. So this is going to be, now we need to first get this, the work done by the motor. We use the work energy theorem there. So it's going to be the work done by gravity, force of gravity on the counterweight plus the work done of the force of gravity on the cage plus the work done by the motor equal to the change in kinetic energy. The change in kinetic energy is 0, and then we substitute the work done by the counterweight there is 5,12 times 10 to the power 5, and then work done by the cage is negative 6.47 times 10 to the power 5 plus the work done by the motor, and then the change in kinetic energy is 0. And then when you do your math there, that is going to be the answer there. The work done by the motor, it's going to be 134,750 joules. That's the work done by the motor. And then we go to the formula of the power. Power is equal to the work done by the motor over change in time, and then it's going to be 134,750 divided by the time. It was 3 minutes, you convert it into seconds. So the answer there, if you punch in the calculator, it's going to be 748 61 watts. That's the end of the question, guys. I hope you understand.